All right, let's pick it back up here where we left off. So we had polygon. We could make a couple polygons, but yes. Oh man, thank you. It didn't take 2 minutes this time. You were able to catch me like 10 seconds in. I knew I had the button too. Oh. All right. So triangle is a polygon. It knows how to do area, but all by itself, polygons can't really do area. So if we were to make a polygon, just a generic polygon, let's just add another button here, why not? This is the best UI ever. We'll call this one add polygon. We'll make this and we'll take our polygons. We'll add a new polygon with, I don't know, number of sides. How about random dot, what is it? New random dot next. Let's do between 1 and max value exclusive of the upper bound. Sure, how about 10? So we'll get 1 to 9 for a random number. And then the name of it here then, we'll just call generic polygon. We'll add the polygon and then we'll call our update polygon label code. So we should be able to add a random polygon. But now our code crashes here because we have a not implemented exception. We don't know how to compute area of a random polygon. So we could either figure out how to skip it in our toString, right? Or we can change how this is marked here. And we can say this is abstract. That was the other option we got here, right? Now with area, you can't have a body if you mark it as abstract. So works the same way. Did you do these in C++? No. You didn't? Okay, we didn't get to abstract. That's all right. Area. Nope. Area. Why is it upset with me again? Come on. So if you have an abstract function, you have to say the class now is also abstract. So we go back up and say, hey, this is an abstract class polygon. Now everything's fine. Oops, no it's not. Because if you mark a class as abstract, you can't make an instance of it. It says, hey, I've got some part of my definition. Some stuff works, some stuff doesn't. Because I don't know how it's supposed to work. So now I can't make a new polygon if I've marked it as abstract. Right, so once mark it as abstract, it doesn't work. Now what's fun with this, if I go make another shape here, let's go make, say, how about a trapezoid? Is that the one that has the two different parallel lengths? Yeah. Right. Okay, so trapezoid. Trapezoid. That's a fun word too. If we say, hey, trapezoid is a polygon now, we get some other stuff. The first one, right, is the constructor. Sure, we need that. So we know it has 4 sides for trapezoids. That's okay. Okay. The other thing that it has to do is it has to implement the abstract class. So because we've marked this method as abstract, any class that inherits from it has to implement it. That's part of the rule, part of the contract here. So the easy way to implement it is to throw a not implemented. It's a little bit cheesy, but that's what we were doing before, right? With Polygon, essentially, we're saying, I don't know how to do this. Now, there's a way to do this, right? Trapezoid area. A plus b times height divided by 2. Length of the parallel sides. H is the perpendicular distance between the parallel. How do you get the height then? How do you compute? Oh, you make a triangle. Duh, we can make a triangle. Okay. We can math this. Right? We know math. All right. So get side length, set side length isn't really going to work well for us because we're going to run into some trouble, right? Because these sides, what do you want to call them, 1 and 3, have to be the same, but then you can have different lengths for 0 and 2. Will probably work. So we can add a void or override set side length. So usually we just set side length, but if my side index is equal to 1 or I will say mod 2 equals 1, then we have to set them both. Right? Otherwise, we just set. Because you can set 0 or 2, the top or the bottom, independently, but 1 and 3, we're going to say have to match. So if we are odd, we'll set the odds. Otherwise, you can set them independently, right? So this gets a little funny, and how do they know that we're counting 0 as like the base? I don't know. We could probably come up with some way to tell them that, but it's okay for right now. Or maybe we add some stuff. Let's add a public static int base side index is 0, and then a public static int top side index is 0 or 2, right? And public static int side. Oh my goodness, side. Is it really side? Left and right index, side index equals 1. Maybe we'll call that the left side index, and then we'll also have a right side index. There we go. Why not? So now we've got some nice little static values people can reference here. I think we can say these are read-only too, right? Static read-only. It's like saying they're constant, right? They get set once. So instead of constant, use read-only. Okay. I think you can actually, can you use const? We can use, it doesn't like const now. Oh yeah, okay, yeah, it's suggesting to read-only. So we don't use constant, we just say read-only. They get set once and stuck. All right, so now we can say, hey, if it equals the left side index, right? That's a little bit prettier here, right? Or what, equals left side index, or, you say or? Side index is equal to the right side index. All right, now our code is prettier, right? We didn't change the functionality, but we have prettier looking code. It's prettier, right? All right, good, I'm glad you agree. Okay, so for area, let's go into math land. So a plus b times the height divided by 2. All right, so we need to get the height then. So we'll have a double for height is going to be, so the length of 1 will be the hypotenuse, right? So a squared plus b squared equals c squared. So we need c squared minus a squared will equal b squared. Right, c squared, let's just pause for a second here and do this. A squared plus b squared equals c squared, right? So then that follows that c squared minus a squared equals b squared. So then b, which is the height, right? So then b is equal to the square root of c squared minus a squared. All right, I think we did it right. Yeah, height time divided by 2. Yeah, well, yeah, we can either do that now or later in the formula, I think, right? So height is the square root, math.square root of, so c squared was going to be, c squared is the length, right? But how do we get the a distance? Well, it should be half of the length minus this length, right? The longer length minus the shorter length, take half of that. Should be the distance of the one triangle for a trapezoid, right? I think. This is like geometry, guys. We should really know this. All right, hang on. Let's do GPT. Let's just cheat here. Actually, let's see if it works, I guess. I don't know if we'll actually get good code here or not. Do you calculate the area of a trapezoid in C#. A list of side lengths, where side 0 and 2 are the top and bottom parallel sides. Think that's enough info? We'll try it and see. If it works, I'll be happy. First base, second base, one of the sides. C squared, a plus b times a minus b divided by 4. That's the height divided by 4. Why divided by 4?
Is it divided by 2, divided by 2 again?
Yeah, but why? I don't know. It's so this is, oh, wait, okay, hang on. So the difference in, so a plus b is the lengths of the top. So we add them and then we subtract them? Sure. So it's probably right. I don't know. Is that, anybody? Math majors? No? Not at this point?
4 years.
All right, well, let's try it. Let's see if it works for us here. So C, wait, what was C? One of the sides. Okay, sure. Side lengths. All right, well, how about get side length of 0? Get side length. So RB, get side length of 2, and var C, get side length of 1. I don't know. And then you'd say ChatGPT gave this to me. Come on. ChatGPT might know. Prompt. And what do we ask it here? All right. Is that, oh, yeah, divided by 2, because that's the average length. Right, so the average length, right? And divided by 2? Isn't this, no, that's not average.
A squared minus b squared, I believe. Isn't that?
It's a plus b times a minus b.
Yeah,
So,
but if you do order operations, right? A times a is a squared.
what's the time?
A times b is ab, but then you're subtracting ab plus ab, which gives you nothing, so it's just b squared. A squared minus b squared.
Is it,
It's not a.
is that like foiled?
I think it's.
Wow, that's fancy math. So you do the FOIL. It's been a long time since I took a math class.
Like really college math, because they're in parentheses.
Well, but so like we could FOIL it, right? If we wanted
Put
to.
a squared
Yeah.
minus b squared over 4, right?
I don't think so. Because they're in parentheses. A plus b.
Yeah, but so you can do this, right? Is that the commutative property?
First.
Yeah, but it does the same thing. So like, hang on, we're gonna try this. So like, oh, Bubby's Bagel. I didn't go to Bubby's Bagel. So if a equals 2 and b equals 3, right? We had a squared minus b squared, right? So we'd have 4 minus 9, right? Or we could have 2 plus 3 times 2 minus 3. So that would, if we FOILed it, it'd be 2 times 2 plus minus 6, right? Right? The first, then the outers, and then the inners plus 6 minus, then the outers, 9, right? The firsts, yeah, 4 minus 9. That's fancy FOIL. It's been a while for math. All right, sure. So a squared minus b squared here. So we get, and then all of that divided by 4, because that's divided by 2 divided by 2 for some reason. Where's our c squared minus, so that divided by 4. Sure, it's got to work. We'll see if it works. So we get a height, right? Now we have the height. Now we'll go back to the height is 1/2. Oh, here we go, the area. We'll call that h then, right? A, B, and C, and H. I hate these variable names here. These are terrible, right? So let's rename that. So here's bottom, here's top. Right? If you have to have a comment that tells you what it is, your variable name's bad, right? So we can yell at ChatGPT for naming these terrible. Top and side. And then H, oh, H is terrible too, height. Okay, we can turn the area. Give it a little format here. What do you think? Do we do it okay? Should we try it out? Then we have a trapezoid. So maybe our button here then, all the way back to our form. Now, if we can't make new polygons, maybe this makes a trapezoid. So we'll take our polygons, we'll add new trapezoid, given, I don't know, trapezoid, trapezoidy. Oh, but we need to be able to set the lengths on this, right? Our trapezoid equals that. And we can call set side length. All right. Valid length for trapezoid, I have no idea. About 4 for 0. Oh, let's make it a rectangle, right? Because then the math should work. Because we know what the lengths of a rectangle are, right? Does that work out? Right? If it is a perfect rectangle, a squared minus b squared, that's how we can check the formula, right? Because
A rectangle is 2 triangles.
well, so the bottom of the times the top, right, will be 0. So 0 divided by 4 will be nothing, and you just have side times side, the square root of that, for the height. Which should be right, you know? So that if the side is exactly the height, the square root of side squared is height. Okay, the math checks out. I think it's going to work. All right, so then we just need the lengths of, where did our code go here? You didn't know we'd do this much math in this class, did you? All right, and then set the side length of, we'll make it a square, right? Why not? Squares are fun. And 3. Oh, thank you. So adding a polygon, we get a trapezoidy here. Area of 16, perimeter of 16. It's a square. All right, I think it checks out. So now we have an abstract class here. The whole point of an abstract class is they share some pieces here, but the rest of the functionality that I really want, I don't have yet, and I'll implement it in the child classes. So we can force someone to do that by marking it as abstract here. So that's the idea with abstract classes. We did toString, we did base classes. You can cast things for fun if you want, so we can force them to be certain types. So we haven't done anything new yet in any of these, right? That we haven't added any new features or functionality. But some of these, we might want to add new things. I don't know why. Let's say we wanted to. So for trapezoid, maybe we want to add a new function, like void. Now let's return a string. How about get trapezoid? I don't know. I'm running out of ideas here. But if you want to get a trapezoid, return I'm a trapezoid. So as we're looping through, because we're treating them as the polygon type, right? Here in my polygon, there is no get trapezoid because it doesn't exist in the polygon class. Right? Because I'm treating them as their parent type, I only have the functionality that is defined in the parent class. Because I don't know what subclass it is currently at compile time. Now at runtime, when it's running, we can go and do some cool stuff. So I can say, hey, I want a trapezoid, and then I can try and cast the polygon as a trapezoid. It's been too long of a day. As a trapezoid, right? So this will force it or try and cast it, say trapezoid, here. And I can say, if my trapezoid is not null, then we'll go and take my text and add trapezoid.get trapezoid, because we wrote a method that exists in the trapezoid class. So if I'm treating it as a trapezoid, I can go use the trapezoid methods. But when I try and cast it, it might be null. So if I add some triangles, right, unable to cast it. Well, I can't cast a triangle as the trapezoid type. That one crashes on me. Okay, well, crashes on me. So we can check the type of first. So I say, hey, if the polygon.getType is equal to trapezoid, nope, that's not type of the trapezoid. Here we go. If it is one of those things. So we can say, hey, while it's running, figure out what type it is. So look at the polygon's type here. See what type it is. If it matches the type of the trapezoid class, let's go do something. So we get this really cool runtime polymorphic behavior. So if we add a triangle, my polygon we know is a triangle, right? It knows it's the polygon here is the triangle class. All right, so that one is not true. Doesn't work. That's fine, we can continue on. But now if we want to go add a actual trapezoid, right, the first one's nothing, but the next polygon now, it is a trapezoid. The type of this one matches the type of the trapezoid class. So while the program's running, we can interrogate the actual class of something, which is super fun. So now we can get that behavior that we want. Oh, we keep forgetting the new lines, right? And this says, hey, I'm a trapezoid. We should add in some new lines, shouldn't we? Plus environment.new line. There we go. So if I add polygons, let me take out the breakpoint here. You get trapezoides, more trapezoides. We should do more new lines, I guess. So I can add trapezoids or I can add triangles, right? And as it loops through, it's looking at it at runtime. This is really neat. So you can also try then the as keyword, because that's kind of annoying, right? So we say, hey, as instead of all this mess. That's what we were trying to do the first time. So we can say, hey, my bar trapezoid as polygon, no, trapezoid, polygon? No, hang on, what's my, no, equals, there we go, polygon as a trapezoid. And if my trapezoid is not null, right? Oh yeah, so we can just do this line. So again, what we're saving here is one set of indentation, essentially. Because we hate indentation. If you have to tab stuff in, it makes us sad, right? We've already used trapezoid. Sure, trapezoid 2. Trapezoid 2. So either syntax here should work for us. Just little syntax shortcuts, right? We have rectangles, they still work. Okay, so other things you might have noticed, we don't have access to polygons attributes, right? If we mark this thing as private, we can't get its side length. If you want your child classes to have direct access to it, we can mark this as protected here. And then in Polygon, we can go in, now we can go, or other classes, we can go and access side lengths. So protected means the child classes have access. Right, does the protected access modifier ring a bell? Do we use that one in 200? No, we're doing a bad job in 200 then. That's okay. So in rectangle, instead of calling set side length every single time, because it's kind of annoying, right? I mean, I could do that, but now I'll have access and I can just say my side lengths, at the side index. So at 0 equals the side length, right? We can just do it directly here, right? Direct access, the protected modifier. Modifier? Yeah, there's an I there, right? Either way works, right? We can still use the public functions, but now we also have direct access. Because we said, hey, this is protected. Me and my subclasses, my child classes, my base classes, or derived classes have access. So we can use that modifier if we want to give them access to it. And then, of course, because you can do that, you can also prevent yourself from being inherited. You can add a sealed modifier to your class and say, this class cannot be inherited from. This is really obnoxious, but some people do this. A lot of the library classes have this for, I don't know why, right, where you can't inherit from them. That's okay. All right, that's a lot. How you feeling? Let's see. We talk more about classes. Yeah, we did classes, object-oriented design. Inheritance, we did inheritance, our base classes. Let's see. I think we're pretty good. What do you think? Let's see. I think, because that leaves us interfaces and the rest as we go for next week. Oh yeah, polymorphism, right? That's the last little piece. This virtual, the override keyword, abstract. Yeah, we did those. Is the book still doing okay? Anybody still reading it? It's worth $30, right? Not a bad book. It's not a $200 textbook, but okay, cool. I think the last piece here, using the new keyword is really ugly. Don't do new. Instead of override, so sometimes it suggests you want new. You almost never want new. New is like the opposite of overriding. And it's saying, I want new behavior, I don't want to override the old behavior. And it's super weird and confusing, so just don't use it. It's probably easiest that way. All right, I think we can actually call it a day then, so we'll have a little bit of time we can work on Yahtzee. If you did partner up, I got a couple partners. So I got shared GitHub repository access. A couple things when you're using GitHub, if you both change the same file and try and commit, it will get a little confused because it won't know which version to keep. Usually you can fix it. Visual Studio actually has some tools for that. I'll say, hey, which versions do you want to keep? And you can tell which versions you want to keep or which lines. Sometimes it gets confusing though. So send me a message or shoot me, call me if that comes up. We can do a little screen share and figure it out. But once you have a commit, your snapshot, you can basically always go back to it. So if it gets super weird and you're like, hey, I lost half of it because I had a commit and then they had a commit and then it did a dumb thing, we can go back to it. It won't be the end of the world, okay? But reach out sooner rather than later. Like the longer it takes to come back and fix it, the more issues we might have with it. So should be pretty good there. So we got Yahtzee due next week. So we'll finish up this last little bit of object-oriented programming, and I'll go over my Yahtzee solution that takes me about an hour to build. Most of it's me dragging buttons around the screen and labels, which is really tedious. So if I actually come with that pre-built, is that okay? I won't show you how to drag all the buttons around. I'll steal that from last time, and then we'll just write the rest of the code for it. That's the interesting piece, okay? We can go from there. All right, so while we work on the project, I've got the quiz out there for classes and unit testing already. I'm finally maybe catching up now that it's February. We'll just pretend January didn't happen here. We'll go from there, okay? All right, awesome. Thanks, folks.